So now we'll look at an easier one. This is page 194, number 20. So when you get down to these ones, it just says, find the extreme values of the function and where they occur. So we need x and y coordinates. None of these have intervals. So basically we're looking for maxima and minima for the entire function, the entire domain of the function. All right, so this is a really nice straightforward one. We're going to look for critical points. We need to check critical points and endpoints. There's no interval, no endpoints. We just need to find the critical points. So all we have to do is say y prime is equal to 3x squared minus 2, and then we need to say that equals 0. There's no numerator, no denominator. It's just where is the derivative equal to 0. So in other words, the derivative is never undefined. The derivative is a parabola. It's never undefined. So there are no places where f prime is undefined. Y prime in this case is undefined, but there are places where y prime is 0. So 3x squared equals 2, x equals plus or minus the square root of 2/3. Right? I mean, if you want, it's what, square root of 6 over 3, right? Square root of 6 over 3. Okay, and so now we just need to determine which is a max, which is a min. But by the way, in this case, look, this is a positive cubic. Since this is a positive cubic, I know what this graph looks like. So I know that the negative one is the one to the left is a min, and the one to the right is a max. The one to the left is a max, and the one to the right is a min. I don't know why I can't say that. So we already know that negative square root 2 over 3 is a min, and positive square root 2 over 3 is a max. But can we justify that analytically? All right, so let's look at our first critical point is x equals square root 6 over 3. So what happens to y prime, which is 3x squared minus 2, when x is less than square root 6 over 3? And what happens when x is greater than square root 6 over 3? All right, well, if I take square root 6 over 3 and I square it, then I'm going to get 6 over 9, right? 6 over 9. And then if I multiply that by 3, then I'm going to have 6 over 2. I'm going to have 6 over 3, which is 2, and then I'm going to subtract 2. So I'm going to get 0, which we knew. All right, so if the x is a little bit less than square root 6 over 3, then this 3x squared is going to be less than 2. So I'm going to have a number here, this 3x squared. If x is less than square root 6 over 3, then 3x squared over 2 is going to be less than 2. So if I take a number that's less than 2 and I subtract 2 from it, I'm going to get a number that is negative. Right? When x is greater than square root 6 over 3, y prime, which equals 3x squared minus 2. Well, now, if I take this number square root 6 over 3 and I square it and multiply by 3, I'm going to get 2 again. So if I take a number slightly larger than square root 6 over 3, I'm going to get a number slightly larger than 2. And then when I subtract 2 from it, I'm going to get a positive number. All right? So y has a min at x equals, I chose the positive one first, square root 6 over 3, because y prime changes negative to positive there. All right, and that's what I said. The min was going to be at the positive one, and then you can do the same thing for the max. These are our first derivative tests. So this is f dt for x equals square root 6 over 3. Now we'll do for x equals negative square root 6 over 3, and we'll do our first derivative test. All right, so then y prime equals 3. Oh, I keep forgetting my top of this, the way I organize this. So when x is less than negative square root 6 over 3, and when x is more than negative square root 6 over 3. Okay, so here's where this is going to get a little bit tricky. If x is less than negative square root 6 over 3, I'm going to have a number whose absolute value is slightly more than square root 6 over 3. So when I square it and multiply by 3, I'm actually going to get a number that's slightly larger than 2. So you have to kind of think about it that way. Then if I have a number that's larger than 2 and I subtract 2, and then I'm going to get a positive number. Likewise over here, when I look at my y prime is 3x squared minus 2. Okay, if I take that negative square root 6 over 3, I take a number slightly larger than that, I'm going to get a number whose absolute value is slightly less than square root 6 over 3. So that when I square it and multiply by 3, I'm going to get a number that is slightly less than 2. And then when I do that number minus 2, I'm going to get a number that's less than 0. So I can see that y has a max at x equals negative square root 6 over 3 because y prime changes positive to negative there. All right, and that's a full analytic justification for all the maxes and mins. Now, but I still need to say that because I didn't include the y coordinates in what I did up here, and the problem asked for them, so I need to take this square root 6 over 3 and plug it into the original equation. Yeah, that's going to be a little bit tricky. So probably calculator time on that one. I mean, you could do it without a calculator. We want to be crazy? Sure. What is y of square root 6 over 3? It is square root 6 over 3 cubed. All right, you can just go to the calculator on this if you want, but I'm just crazy. Just crazy like that. All right, so what is this going to equal? So I'm going to have 6 square root 6 over 27. All right, minus 2 square root 6 over 3 plus 4. So I'll probably reduce this one. So then I have 2 square root 6 over 9, 2 square root 6 over 9. And I want a common denominator with this one. So let's make this one minus 6 square root 6 over 9 plus 4. So I'm just working with the radicals just because I can. So I get negative 4 square root 6 over 9 plus 4. That's the y coordinate. Okay, and then my y of negative square root 6 over 3. Let's see. This one's going to change sign and this one's going to change sign, but this one's not. So I can copy from my work up here and say, now what I'm going to have is negative 2 square root 6 over 9 plus 6 square root 6 over 9 plus 4. So now I'm going to end up with positive 4 square root 6 over 9 plus 4. All right, so my final conclusion is going to be our minimum value is the negative 1, so negative square root 6 over 3 comma 4 square root 6 over 9 plus 4. And our max is going to be the positive 1, positive square root 6 over 3 comma 4 square root 6 over 9. This should be negative plus 4. There you go. Okay, so the algebra is a little tricky, but I could have made it easier by just making these into decimals instead of insisting on working on the radicals. The basic process, derivative equals 0, 2 critical points. This should have a plus or minus there. 2 critical points, first derivative test on both of them. One's a max, one's a min. Boom. That's what we call an easy one. Okay.